If someone's recording, record.
Kavisha is recording. Yeah.
Okay, let's start. Probability distribution. So probability means how likely a certain event happens. No, so probability distribution means how. Now there's a random variable. So random variable is it's just a fancy word for what do you call a quantity that can take different values randomly. Say like a lottery ticket. ඒක දෙන values අපි දන්නේ නැහැ මේක random variable. So in this random variable how probabilities spread for different values of this random variable is called probability distribution. So there are two types. One is discrete probability distribution. Other one is continuous. Discrete probability distribution means how it can the probability these can take only countable values or finite values. Continuous ones they can take infinite. Continuous, for example, we can say now discrete is a definite number. That means something like a number of heads when you flip a coin. Definite no? බාග ගණන් එන්න බෑනේ. So continuous or you take infinite values, something like height of a student. යම් කිසි පරාසයක ඕන තරම් height ගන්න පුළුවන් අපිට infinite. And then temperature, time. So there are many examples. So when we are discussing discrete and continuous probability distribution, you take two what you call properties. One is expectation. We write this one as EX, and then variance. We write it as YX or VX, whatever you like. Expectation is same as mean. Same as mean. But the equation here is sigma x px. X is the value, px is the probability. Okay? And then variance, we can derive from this ex. Yx means ex squared minus ex whole thing squared. So those are the two properties they talk. And then there are different calculations that can be performed for expectation and variance. So expectation things you need to know are we have something like this. Ax plus b. How you perform this one is you take a out. So a ex plus b. B is a constant. There's no x variable, so it's like that. Then another one is ex plus ey. Get ex plus y. Likewise. The same thing can be done for ex minus ey. So ex minus y. Okay. And then for variance, May if you have questions, ask. Lama kodidana inne maaki hakkunata. YX. So there are different calculations you can do here. One is we have something like this. You take C out, but C becomes square like this. And then one important thing, yx plus y altogether can be written yx plus yy. You can expand it. But yx minus y, you can't write yx minus yy. You have to write yx plus yy. Okay. Both in plus and minus cases, it is plus. Okay. That's the only thing you need to remember there. And then those are the properties you need to know in variance and expectation, which is mean. And we'll go for discrete probability distribution. Okay. Discrete. Also, you need to learn probability mass functions. Now, when I said that earlier, random variable takes values of when that takes values, you can write this random variable as a function. Okay, so there are two type of functions for this is called probability functions. Two types of functions for discrete and continuous. For discrete, it's called PMF, probability mass function. For continuous, it's called PDF, probability density function. Okay, we'll discuss these separately. Now, in discrete random variable probability distributions, you have, I think, 7 distributions. Yeah, I'll try my best to cover all of them. Um One is uniform uh, Bernoulli. Binomial. And then Poisson. Geometric. Negative binomial. And hypergeometric. Okay, we have to learn uh, for each case. Now these are discrete, no? So PMF, EX, and YX for each and every function. So we'll take uniform. Now it's easier to remember from the word uniform. Uniform means evenly distributed. That means all the values of x here have equal probability. Something like tossing a coin. Chance of getting head is half, chance of getting tail is half. If it's a fair coin. So likewise, you have to remember the equations too. Okay, so the PMF for here is 1 over n. So this n is a number of, what do you call that? Okay, before these things start, you have to know that discrete, what do you call discrete random variable probability distribution. There are two conditions you need to suffice, satisfy. Discrete probability distribution, like probability distribution of discrete random variable. Two conditions you need to satisfy. One is this PMF should be between 0 and 1. Okay, they can't take negative values, they can't take values more than 1. Other one is summation of all the PMFs should be equal to 1. That means when you add certain uh, what you call probabilities, summation should be 1 for everything. Okay, those are the two conditions you need to satisfy in probability distribution of discrete random variable. Okay, and then uniform. Let's take uniform. PMF is 1 over n. This n is different possible values the variable can take. For example, uh, what is an example? Let's say we have a fair die. Now for x, there is PMF. So for 1, 2, 3, 4, 5, and 6, the probability is 1 over 6. Values that can take higher ගන්න පුළුවන්. So 1 over 6. Okay. Now you have පැති 6යි. පැති 6 තමයි මේකේ ගන්න පුළුවන් number of what do you call outcomes here. So that is why it's 1 over n. And these things we have to cut apart. And n plus 1 over 2 is the expectation. Variance is n square minus 1 over 2. Now in the previous example, now n is 6 no for the fair die. So ex is 6 plus 1 over 2, which is 3.5. Yx is 6 squared minus 1 over 2, 35 volt. Something like this. Okay. That is uniform. Bernoulli. Now Bernoulli is a trial. So how this trial happens is there are two outcomes for this kind of distribution. One is success, other one is failure. We assign probabilities. For success it's P, for failure it is 1 minus P. Okay. So there are in a Bernoulli trial, also there are different conditions for it to be a Bernoulli trial. First one is it has only two outcomes. Okay, and then the probability of success is constant. This is constant, and then trials are independent when repeated. Independent when repeated. So that those are the three conditions that should satisfy for it to be a Bernoulli trial. With තුනම තියෙනවා නම් then you can use Bernoulli distribution. Now for this one, uh, the PM of this one is either P or 1 minus P. P when x is 1, 1 minus P when x is 0. X is 0 means failure, x equals 1 means success. Also 0 can happen but no need to write. And then, no, it should be removed. Yeah, 0 also can happen. Then expectation, easy because expectation here is P. This is the expectation. P, which is mean. Variance is P into 1 minus P. In Madam Stewart, she has substituted Q. Q is 1 minus P. So if you like it, you can remember PQ, but it's easier to remember P into 1 minus P. That is a success probability into a failure probability. That is its variance. Expectation is probability of success. Okay, and then next one, binomial. Okay, this one you need to learn some. Now binomial is actually Bernoulli repeated several times. Bernoulli වැඩි කරොත් n number of times, then you get binomial. So binomial also has several conditions. One is two outcomes. Other one is success is constant. Trials are independent. And n number of times repeated. අර features තුන, the same features from the Bernoulli, but it's repeated n number of times. But here you need to learn some things. So there's a notation. We write this one as x equals to b n comma p. So when in the paper it is given, මේ වගේ ප්‍රශ්නයක් ආවා assignment එකට. When you have something like this, that means you have to interpret. You have to take now. They won't give separate information for n and p. They will give a statement like this. So you have to what do you call, decrypt the meanings of these ones. So n is number of trials. This one is p is success probability. ගානක එකපාරට x goes to being 6,0.25 කියලා දුන්නොත් 6 කියන්නේ number of trials 0.25 කියන්නේ success probability. හැම distribution එකම මේ දෙක එහෙම නෙමෙයි එන්නේ. වෙනස් වෙනවා එක එක distribution වලට. So you have to remember number of trials and success probability for binomial. Okay. And for the PMF, of this one binomial. Now in the Bernoulli, what you had was P and 1 minus P. No? So using these terms, they make a new PMF for binomial is NC. I don't know the terms. NCX, yeah. NCX P to the power X 1 minus P to the power N minus X. Okay, this is the probability of X for a binomial. So how do you use this one? Now in let's do an example. Now if you have something like this, okay, this one. Okay, now let's take for example a basketball player has a 60% success chance of putting the ball in from the ring, okay, to the ring, okay, and he takes 10 shots, okay, and what is the question should be what is the probability that the seventh shot goes through the ring. So 60% is the probability of success, 10 is N, 7 is X here. That's how you now if you have a question, first of all ලේසිම ක්‍රමය කරන්න මේ variables අඳුරගන්න. So P is success rate, N is 10, X is 7. So you apply these to here. Now in this case Px equals 10C7 0.6 to the power 7, 1 minus 0.6 is 0.4, 0.4 into 10 minus 7, 3. This is the probability for that question. So likewise, may gonna cover like assignment again. So if you have this kind of a question, use this. Okay. That's for binomial. Expectation. Expectation is easy. Now in Bernoulli, expectation is P. Variance is P into 1 minus P. In here, binomial, expectation is NP. Variance is NP 1 minus P. N is number of trials. Number of trials it's repeated. Okay. Okay. Cut it like then Poisson. Okay, Poisson. Poisson distribution easiest way to find whether the question is a Poisson is if they have given the question in a rate like speed or time or average speed or something like that, it should be Poisson. Rate distribution that is definitely Poisson. So PMF here is, this you should remember, e to the power minus lambda, lambda to the power x over x factorial. Here, this lambda here is a mean. Okay, mean කියලා තමයි ඒගොල්ලෝ කියන්නේ. එදා ක්ලාස් එකේ මිස් කිව්වෙත් mean කියලා. I can't remember that properly. Hold on, give me a second. Oh, it's on. Anyway, they will give the lambda. So we don't know what lambda is. So they'll give something like this. අර binomial වලට තිබ්බ notation එක වගේ Poisson වලට notation එකක් තියෙනවා. So they have something like this. X goes to P O lambda. We have in the question paper, if you have something like this, that means 6 is lambda. So you substitute here and solve it. Now e to the power x here, this one is e to the power x. Sorry, expectation is lambda. Variance is also lambda. වෙනස් වෙන්නේ නැහැ. දැන් මෙහෙම questions එන්න පුළුවන්. If x goes to Poisson 2, find p x equals 3, x equals 2, and p x equals x greater than or equal 4. Something like this. So how do you solve this one? Now we know that here lambda is 2. Now p x equals to, how do you do that one is, first of all write the equation e to the power lambda into lambda e to the power minus lambda, lambda to the power x over x factorial. Then you substitute the x here. Lambda is also 2 to the power 2 factorial. This is easy. Now if you have an interval, now that's where the problem is. Then it says p x should be greater than or equal 4. Now if you take a number line, if this is 4, should be this one and everything else here. Now this number line continues till I don't know how many numbers. So in that case, what can you do is, we know this entire number line, when you add everything, it should be 1 probability. So what we do is, for px greater than or equal 4, instead of adding px equals 4, px equals 5, px equals 6, instead of doing this one, we are doing 1 minus px equals 0, px equals 1, px equals 2, px equals 3, like this. Now you can take the value for px greater than or equal 4. For each and every of these, you have to use the equation e to the power minus lambda, lambda to the power x over x factorial for each and every scenario. That's how the question is solved. Okay, that is Poisson. Geometric easiest way to identify whether the distribution is geometric or not is that in the question, if they say something like, what is the probability they get a first success or first failure, if they say something like that, that's definitely geometric. So geometric In geometric, PMF is P into 1 minus P x minus 1. Okay. These things you have to remember. Ex is 1 of E. Variance is 1 minus P over P square. Okay. I think that's it for geometry. This one also has a notation, but she hasn't given that in the uh, note, so I don't think that will be needed. But in case, this is the notation. Okay, if they give something like this, P is the probability of success. 1 minus P is probability of failure. Negative binomial. Now, easiest way to identify negative binomial is now in geometry, it's the first success. In negative binomial, it's nth success. If that's the idea, then you should use negative binomial. So this is actually an improved version of binomial. PMF is n minus 1 C x minus 1 k. X minus 1 p to the power x minus 1. That's it. P to the power x 1 minus p to the power n minus 6. The only difference here is that in binomial we had n c x, no, here n minus 1 c x minus 1. You know factorials, right? So n minus 1, you solve this one, you get n minus 1 factorial over n minus 1 minus x minus 1 factorial x minus 1 factorial. Okay, and ex is k over p, sorry, x over p. Variance is x 1 minus p over p square. In all the, what do you call, the distributions, p is success, 1 minus p is failure. Okay. And then last one, hypergeometric. Now hypergeometric, easiest way to recognize this one is if a situation is given where they do like sampling. This keyword is important. Without replacement, then it should be a hypergeometric distribution. Without replacement wage keyword එක තියෙනවා නම් definitely hypergeometric. So this one a bit tricky, not tricky. Equation locally they have p x equals k my k cx minus k minus x over NCN. Okay, so I'll tell you what these meanings are. Uh, so n and k, also x. X is the variable, n is the total number of somethings in that question. Uh, is that Mhm. Hypergeometric? I can't remember. Let's do question. Then I'll remember what's what. Anyway, equations. Ex is a simple nk over n, capital N, and variance is okay. That's a huge equation. Nk n minus k n minus n over. Okay, this is the variance. I think you should like by heart everything here. Hypergeometric, let's do a question. I can't remember. Okay, if something like this happens. For example, uh, okay, now box contains 10 red balls and 20 blue balls. Okay, and then if you randomly select 5 balls without replacement, okay, what is the probability that exactly three of them are red? Three of them are red from here. Okay. Now how? Now there in the question it says without replacement. So definitely hypergeometric. So how to solve this one is P x equals k k kcx n minus kc n minus x n c n. Okay. Now here kcx k is 10. Now from the red balls I have to select this 3. So here it should be 10. See now from 10 you select 3. Okay, and then you have to see how many. Now if you select 3 from red, other two should be blue. No? Other two should be blue. So that one how we write is from 20 to select 2. Okay, and then the total. The total is how many balls altogether? 30. From 30 you select 5. That is how I put it in my head. I don't by heart the equation. I write something like this. Now from the five balls we select, three should be red. No. Now what's the probability of what is like the probability of taking this one? 10C3. Not the probability. I don't know the word for that. Permutation. No, combination. Okay. How many ways we can take these three? From 10 red balls, you get 3. And here, then we have to multiply this by, now, if this one is, if 3 balls out of 5 is red, 2 balls should definitely be blue. No? So we write a combination of take how many ways we can take 2 balls out of 20. So 20 C2 divide by the whole probability. We have to take 5 balls from these 30 balls. No? So 30 C5. That is how I remember. It's easy that way. I can't remember this all symbols and all, but this is the easiest way to you can solve this. And that's it for distribution. Shall we do continuous? Let's do continuous too then. Did we do the EX and PF? Yeah. Okay. Recap. How you can identify, now there are different, now there are 7 distributions you need to remember. So easiest way is to identify whether the question is which distribution is which. Okay, uniform, equal probability. Bernoulli, one trial. There's only one trial. Binomial, n number of trials. Poisson, Poisson time interval. We have a fixed time interval. If there's a rate or something, when Poisson is involved, then geometric, first success, negative binomial, nth success, hypergeometric, without grid test. This is how I remember. So if it's easier for you, you can use this one. Okay, let's do continuous 2 then. Continuous, I don't think they'll ask much questions because integration is involved. That part is obviously they won't ask. Okay, and okay, but they will give those questions to like find from the table. So there's a table there for those who haven't come to the lectures. Rough table, now you have to read that. Okay, continuous discrete problem, not discrete. What do you call it? Continuous random variable. That means the random variable can take infinite number of infinite values. Okay. Now here I mentioned that for discrete you have probability mass function. For continuous you have similarly you have probability density function. PDF කියන්නේ ඒක not කියන්නේ academic lecture also තියෙන්නේ mostly PDF. PDF is probability density function. So like uh, what do you call, probability mass function, you have a PDF. So PDF is fx. Now this fx have two conditions to satisfy. One is fx should be greater than 0, greater than or equal 0. The other one is integration of um, this one you don't need to actually remember. Integration of from plus infinity to minus infinity. Integration of fx should be 1. Fx dx was 1. Now how this one happens is continuous random variable. Easiest way to solve the questions is draw this bell-shaped graph. That is the easiest way to solve the continuous random variable questions. Now, what this one says, this integration part, sorry, differentiation part, no, integration part. So, from plus infinity to minus infinity, okay, plus infinity to minus infinity. So, integration normally means area under the curve. So, this area here should be equal to 1. That's what this expression says. Okay. Yeah, I'll teach you all how to read the table. Also, you need to remember expectation and variance here too for continuous random variable. You don't need to remember actually because integration is involved. Yeah, just right. Here it's integration xfx and y is similar to the other one ex squared minus ex the whole thing squared. Okay. Um, I'll teach you how to do this one. Hold on a second. I'll open the PDF. Okay. Now we had 7 different types of distribution under discrete now. So we have one kind of distribution under continuous. That's called what do you call it? Normal distribution. Normal distribution is a type of continuous distribution. Okay, and it is written like this: uh, x goes to n. This is capital N, just capital M. We have nu and sigma square. So whenever you are given something like this, x goes to n, 6, 25, something like this, that means we have to decrypt the hidden information here. So nu, which is mean, is 6 and sigma square, that means standard deviation is 25. Now standard deviation is not not easily used here. What they use is variance. So how you find variance? That sigma. So 5 is the variance. Mean is 6. That's how you like decrypt the whole thing. And yeah,
Sonali, was it the standard deviation or variance that we get
Lambda
finally?
squared is sorry. Lambda squared is variance. Lambda is standard deviation. Yes, yes. Fatluna. So normally we use standard deviation. Variance पाविंच है. Uh, I'll tell you the reason. The reason is අපිට මේක z කියලා value එකක් පාන්න. If people have done maths, you might know this as z score. Um, how you find this one is x minus nu over sigma. So to get these values, that's how we decrypt the values from here. Sorry, actually, thank you, Jude. It should be mu and variance here. They give you mean and variance. You have to decrypt. You have to only get mean and standard deviation. Yeah, thank you. And okay, there's a separate variation called standard normal distribution. Okay, standard normal distribution. In this standard normal distribution, mean should be 0 and variance should be 1. That if they have a certain value like this, that means it's a standard variance. Sorry, it's a standard normal distribution. Okay, and why this one is used is normally we don't have a table to find normal distribution. We have a table to find standard normal distribution. If you can see the table, I'll show you one. Um, you can see this one. This is kind of like the standard normal distribution table. From this one, you can't find normal distribution. Make a part of the number, but standard normal distribution, yes, of course, you can find. So what we do is, whenever we get a normal distribution, we convert that into a standard normal distribution. How is that? The method is something like this. Now, if we have something like this, I'll take an example. This one more thing. These tables are called Z tables. Z means Z score. So for us, when combined mass provider Z and Z score, but others just remember as Z tables. So now if we have something like this, x goes to normal distribution 5 36. If we have something like this, we can't find this. Okay, we can't find this one. So how you do this one is from the Z tables. So what you do here is uh, අපිට කියනවා find no x is greater than 20. Now this is the question, okay? X goes to normal distribution 536. We have to find p probability of x greater than 20. Now we can't find x from Z table. We have to find z from Z table. So how you convert this x to z is z equals x minus mu over standard deviation. So we apply it to here. Now x here, x minus mu over z. Now once you've done some operation to one side, it should be repeated for the other side as well. So 20 minus mu, 20 minus mu over standard deviation. Now let's take the values here. 5 is the mean. From here, uh, standard deviation is 6. Okay, so we apply the values. X minus nu over standard deviation, you get C. This one. C greater than 20 minus 5 over 6. So once you simplify this one, you get Z greater than 15 over 6. Okay. Then you will get a value something like P Z greater than 2.5. Okay. Now this one we can find from Z table. PZ greater than 2.5. Now there's a method to find that one as well. Now in this Z table, මෙතන මේ ඔයගොල්ලෝ තේරෙනවද දකුණු පැත්තේ කොනේ තියෙනවා. Here, this one. So they have given a bell-shaped graph. Okay, and they define something. That is something like this. The values of this table is valid if මේ පැත්තට આવොත් විතරයි. Right. මේ ටික විතරයි C table එකෙන් ගන්න. I'll tell you from this example now. Here, මෙතන මැද එක බිඳුව. The middle value here is 0. PZ greater than 2.5. Now if we mark this in the bell-shaped graph, this is 0. May have 2.5 here. Now Z should be greater than 2.5. That is this area. Now how do you find this one? Because values of the Z table are given to the other side. මේ පැත්තට දීලා තියෙන්නේ. මේ පැත්ත නෙමෙයි. So how you find this area is there are actually two methods. We know that the area under this graph is 1. So 1 minus up to this you can subtract. Yeah, that's the only method. Okay. You have to subtract Z equals 2.5. That means this area from the whole area. Then you get this part. That's how you get Z greater than 2.5. Minimum value of how? Yeah, something like this. P Z greater than minus 1.5. Now, one feature of this table here is that they don't have negative values. Negative values, positive values with right. So how do you find this stuff? Okay, again the bell-shaped graph. Whenever you have this one, it's easy. Again, I recommend you to draw the graph and then only do it, because sometimes you can get confused. 0, and then we mark minus 1.5. Let's say it's here. So it should be greater than minus 1.5. That means this thing. Now in the graph, they'll only give this part. Then same thing, from 1 you deduct one rolling make deduct කරන්නත් බෑ. We can't deduct negative 1.5 because we don't have negative 1.5. So what you do here is we invert the table. Invert करना क्या है? Zero 1.5. Now this bell graph is a symmetric graph, despite my drawing, and මේටිකම සමාන වෙනවා maybe these two are equal in area. We are talking about the area, so these two graphs are equal. Then what we can do is we can take 1.5 and we can take the value of z less than 1.5. That one we can find. That's how you find the z value. I hope you understood this one. Now make him a z less than negative 1.5 equal. So then what you do is zero negative 1.5. Okay, c less than negative 1.5. That means this side. We can't find negative 1.5 even though it's in the right side, left side, because there are no values for negative in the table, z table. Then what you should do is we should invert the graph. Make graph figure. So how do you get this one? How do you get this one? 1 minus whole thing again. Z less than 1.5. That's how you get this one. Those are the different variations she told us. Anything you need to clarify, anything you need to ask. ඔක්කොම තේරෙනවද?
ගණන් ටිකක් කරමු.
Yeah, ගණන් ටිකක් කරමු. Okay, we'll do some questions. Okay, I'll share the screen. Hold on. Oh, there's another thing I have to teach you all. There's something called empirical rule. As I went to Gava, she hasn't specifically mentioned what empirical rule is, but she asked the question. This is a bit of a theory. Okay, I hope you all can see. Okay, like this. Can you all see? Can't you know? Uh, okay. So empirical rule means uh, the how data is distributed around the mean is called how these are divided is called empirical rule. So empirical rule again mean එකට ළඟින්ම තියෙන මේ කොටස 168ක් normally from a data set 68% of this come near the mean. Then 95%. Now this one is now this is new no? From here to here the length is mu plus sigma. Here it's mu minus sigma. Okay, and then තව variation එකක් තියෙනවා මේ හරියටදී. That means mu plus 2 sigma. Here mu minus 2 sigma. මේ ටිකේ area එකේ amount of data spread වෙලා තියෙන්නේ 95%. Okay, likewise nu plus 3 lambda, not lambda, nu plus 3 sigma, nu minus 3 sigma. ඒ හරියදී spread වෙලා තියෙන data amount එක 99.7% තමයි spread වෙලා තියෙන්නේ. This is really important because assignment එක ඇහුවා plus lecture note like empirical rule කියලා I didn't see that. So මෙතනින් කුප්පිය නවත්තන්න වෙනවා because I don't have the battery and the power is out. Any questions before I stop? Anything you need to clarify? Mama Gomat, I'll make like a model paper like I did for what do you call mathematics for computing. Taking ප්‍රශ්නාවනේ. So let's see. Look at the paper. අමාරු වෙනවා for sure because if you have checked the past papers, those are seen more than. Okay, so paper will definitely get harder. So you have to like know all of them, all the stuff she has taught us, all the equations and everything. Any questions you need to ask, anything you need to clarify? I'll put some questions and answers on the method as well. Anything you need to clarify before I stop you? Jude, ප්‍රශ්න නැද්ද?
නෑ සනාලි.
Okay. So I'll stop for today. Sorry that I didn't know that the light will go out. If any questions, if you have any questions, just message me. I'll be awake from like 6 o'clock to 4 o'clock in the morning. Oh shit. Okay. Okay, not good. Okay, I'll stop the Kuppi for now. Okay. I'll definitely do a paper. So sorry about this and goodbye. Bye, Lama.